word equation. And you have to predict what the products will be. So to start off with, there's some things that we need to remember when predicting products. You need to remember the charge of your ions and ionic formulas to write a balanced chemical formula. The polyatomic ions, they act as a group of atoms in some of our ionic compounds, and so you need to know the charge of them and the formula. You can find that on the back of your periodic table. The diatomic molecules, also known as the Brinkelhoff twins or 7 to heaven, you need to remember that anytime you have bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, or fluorine by itself and not bonded to something else, it's always going to have a twin or a partner or pair, something like that. You need to remember the 5 types of chemical reactions. We have combustion, synthesis, decomposition, single replacement, and double replacement reactions. You need to remember the activity series for your single replacement reactions. The activity series determines if your single replacement reaction will occur or not. And the solubility rules determine the states of matter. But definitely determines for our double replacement reactions if the reaction will occur or not. If you cannot have 2 aqueous products, you have to have an aqueous and a solid, or aqueous and a liquid, or aqueous and a gas in order for your double replacement reactions to occur. So let's start off with predicting combustion reactions. The combustion reactions that we have primarily focused on have been with starting with a hydrocarbon. Burning in the presence of oxygen gas is produced, oxygen gas to produce carbon dioxide and water. And remember, a hydrocarbon is just some number of carbons bonded to some number of hydrogens. So here in this first chemical equation, I have given you the reactants. C2H6 reacts with oxygen to form, and we said it's always going to be CO2 and water when your combustion reactions start with a hydrocarbon. So then we just need to go through and we need to balance this out. We have 2 carbon, we have 6 hydrogen, and 2 oxygen in our reactants. In the products, we have 1 carbon, 2 hydrogens, and 3 oxygen. So if we start off by doubling CO2, that's going to give us 2 carbon, 4 oxygen there, plus 1 there is 5. And then we would need to triple our water to get our 6 hydrogen. That's going to give us 3 oxygen there plus the 4 there, but there's nothing that we can multiply by 2 to get 7. So we need to take a step back, and whenever you get stuck, we said double the first chemical. So that's going to give us 4 carbon and 12 hydrogen. So now we need to put a 4 in front of CO2 to get our 4 carbon. 8 oxygen there plus 1 there is 9. To get 12 hydrogen, we're going to need to put a 6 in front of H2O. That's going to give us our 12 hydrogen. 6 oxygen there plus the 8 there. That should give us a total of 14. And then we need to go and put a 7 in front of O2 to get our 14 oxygen. So this was a partial skeleton equation. I may also give you a partial word equation. And this one says the combustion of liquid benzene. So we know, I gave you the formula for benzene, C6H6. It tells us it is liquid, so we're going to indicate that with an L for the state of matter. And that's all the information that we're given. But we are told that it is combustion. Fire needs oxygen to burn, so oxygen is always going to be the other reactant in a combustion reaction. And then, since we have this hydrocarbon burning in the presence of oxygen, we're going to have CO2, which is a gas, and water, which will be liquid. So there's our skeleton equation. Then we just need to go through and balance this out. In the reactants, we have 6 carbon, 6 hydrogen, and 2 oxygen. In the products, we have 1 carbon, 2 hydrogen, and 3 oxygen. So if we put a 6 here, that's going to give us 6 carbon. 6 times 2 is 12, plus 1 there is 13. And then we're going to put a 3 here to get our 6 hydrogen. It's going to give us 3 oxygen plus the 12 there, which is 15. And again, there's nothing that we can do to balance this out, so we need to take a step back. And we need to double the first chemical in our chemical equation. So that's going to give us 12 carbon, 12 hydrogen. So then we need to put a 12 in front of CO2 and get our 12 carbon. 12 times 2 is 24, plus 1 is 25 oxygen. Then we need 12 hydrogen, so we're going to put a 6 in front of H2O. That's going to give us 12 hydrogen. 6 times 1 is 6, plus the 24 there is going to give us a total of 30. And so then we need to put a 15 in front of O2 to get our 30 oxygen. And now it's balanced. So that is combustion. For synthesis, synthesis reactions have 2 or more reactants that are going to form one product. You need to be sure to balance the charges when you are forming that one product. So here we have silver, solid silver reacting with chlorine gas. And so we want to form silver chloride. So we're going to look up silver, even though it's a transition metal, we said it's always going to be a 1+. Chlorine, look at your periodic table, you should be able to determine that that is a 1-. So our formula is going to be AgCl. And then you can look at your solubility rules to determine the state of matter, and I believe that this should be a solid. So then you can go through and balance this out. In the reactants, we have 1 silver, 2 chlorine. In the products, we have 1 silver and 1 chlorine. So in order to balance this out, we're going to need to put a 2 in front of silver chloride. That's going to give us 2 silver, 2 chlorine. And then we need to put a 2 in front of silver to get our 2 silver. And then we'll go back and fill in with a 1. And that is now a balanced chemical equation. And yes, I double checked my solubility rules, and silver chloride is a solid. So then our other synthesis equation, we have calcium metal and nitrogen gas. And that's all we're given. So these are the reactants in a synthesis reaction. Calcium is a metal. And anytime you have a metal by itself, you're always going to have one, and it's going to be solid unless it is mercury. Nitrogen gas, nitrogen is a diatomic molecule, so it's going to be N2, and it's going to be marked as a gas. So we want calcium and nitrogen to form a compound. Take a look at your periodic table. Calcium should be a 2+, nitrogen would be a 3-. So the formula there is going to be Ca3N2. And this is not on your solubility rules to determine the state of matter, so I would not ask you to do that. Label them for what you can, and you can omit those that you do not have the information for. So then we need to balance this out. In the reactants, we have 1 calcium and 2 nitrogen. In the products, we have 3 calcium and 2 nitrogen. So in order to balance this out, we just need to put a 3 in front of calcium. It's going to give us 3 calcium, and then we can go back and fill in with 1s. So that is synthesis. In order to predict decomposition, you need to remember that you are going to have 1 reactant, and it's going to form 2 or more products. So we're going to split NH3 up. This is ammonia. Well, there's only 2 elements that make up this compound, so we're going to have nitrogen and hydrogen split up somehow. If you just split this in half, you're going to end up with nitrogen, but we know since it is a diatomic, there's going to be 2. And that's going to be a gas. And then hydrogen is also going to be a gas. And that's how we're going to break this down into 2 products. Then we need to go through and we need to balance this chemical equation. And so in the reactants, we have 1 nitrogen and 3 hydrogen. In the products, we have 2 nitrogen and 2 hydrogen. So in order to balance this out, we need to even out our nitrogen and our hydrogen. Okay. So we're going to double in the first one. That's going to give us 2 nitrogen and 6 hydrogen. So now our nitrogen are equal. In order to balance out the hydrogen, we're going to put a 3 there, and that's going to give us 6. And then we'll go back and fill in with a 1. The decomposition of iron 2 oxide. First, you need to remember that this 2 is giving you the charge on iron. So iron has a charge of 2+. We can look at the periodic table to determine oxygen's charge because it's always going to be the same. Oxygen is a 2-. So in order to write our formula for iron 2 oxide, it's just going to be FeO. And then you can take a look at your solubility rules in order to determine the charge of or the state of matter for iron 2 oxide. So that is going to be a solid. So that's our one reactant that's going to split into two or more products. So one of our products is going to be iron metal, which will also be a solid. And then oxygen, which is a diatomic, so O2, and it's going to be listed as a gas. Then we need to go through and we need to balance this out. So iron, we have 1. Oxygen, we have 1. In the reactants, in the products, we have 1 iron and 2 oxygen. So then we need to double iron 2 oxide to get our oxygen equal. And then we're going to put a 2 in front of iron to balance this out, and then go back and fill in with a 1. And that is decomposition. In order to predict single replacement reactions, you'll need to use the activity series to determine if the reaction will occur. This is listed for you on the right-hand side of the back of your periodic table. Remember that a metal is going to replace a metal or hydrogen. A non-metal is going to replace a non-metal. So in our equation here, we have fluorine gas reacting with aluminum chloride. Well, fluorine is a nonmetal, so it's going to want to replace chlorine. Take a look at your activity series. Fluorine is at the top of the nonmetals. It is above chlorine, so this reaction will occur. So we're going to form aluminum fluoride. On your periodic table, you should be able to determine that aluminum is a 3+ charge, and fluorine is a 1- charge. So in order to balance this out, our formula is going to be AlF3. And looking at your solubility rules, this should be aqueous. And then chlorine got kicked out of the compound, so it's all by itself, but it's a diatomic, so there's going to be 2. And chlorine is also going to be a gas. Then we need to go through and we need to balance this out. In the reactants, we have 2 fluorine, 1 aluminum, and 2 chlorine. In the products, we have 3 fluorine, 1 aluminum, and 2 chlorine. So now we're going to put a 3 in front of fluorine. That's going to give us 6 because we're looking for a common factor here. That means we're going to have to put a 2 in front of aluminum fluoride. That's going to give us 2 aluminum and 6 fluorine. And then we are going to need to put a 2 here to get our 2 aluminum. That's going to give us 6 chlorine, and a 3 here to give us our 6 chlorine in the products. In our next chemical equation, it says that we have magnesium metal. So magnesium metal, we got one of those, and it's going to be solid. And it is dropped into hydrochloric acid. Anytime you have the hydro, it means hydrogen, which is always going to be found in an acid as the cation, is paired with a single nonmetal. And in this case, the chlor is referring to chlorine. Acids are always going to be aqueous for the state of matter. So magnesium is a metal. We don't have a metal in hydrochloric acid, but I also said that a metal can replace hydrogen. So magnesium wants to replace hydrogen. If you take a look at your activity series, magnesium is higher than hydrogen on the activity series. So we want to form magnesium chloride. Magnesium is a 2+ charge. Chlorine is a 1-. So the formula is going to be MgCl2. In looking at your solubility rules, the state of matter is going to be aqueous. And then we're going to have hydrogen all by itself. It's a diatomic, so H2, and this is going to be a gas. So now we need to go through and we need to balance this out. So we have 1 magnesium, 1 hydrogen, and 1 chlorine in the reactants. In the products, we have 1 magnesium, 2 hydrogen, and 2 chlorine. So in order to balance this out, we need to put a 2 in front of hydrochloric acid. That's going to give us 2 hydrogen and 2 chlorine. It's balanced, and then we're going to go back and fill in with 1s. And our last type of reaction that we're going to talk about predicting products is predicting double replacement. In a double replacement reaction, the cations switch. So the positively charged ions are going to want to switch, and you want to be sure to balance the charges. And you're going to use the solubility rules in order to identify the products. In this case, we have iron 3 chloride, which is aqueous, reacting with ammonium sulfide, which is also aqueous. So we want iron and ammonium to switch places. So we know that iron is going to be a 3 plus based off of this formula. And we want it to go with sulfur, which is a 2 minus. So our formula is going to be Fe2S3. And look at your solubility rules, that is going to be a solid. Ammonium, the only positively charged polyatomic, NH4, it is a 1 plus. And it's going to go with chlorine, which is a 1 minus. So this is going to be NH4Cl. And look at your solubility rules. That should be aqueous. Okay, so now we need to go through and we need to balance this out. Remember, if you have a polyatomic on both sides of the reaction arrow, you can count it as 1 unit. So we have 1 iron, 3 chlorine, 2 ammonium, and 1 sulfur in the reactants. In the products, we have 2 iron, 1 chlorine, 1 ammonium, and 3 sulfur. So in order to balance this out, I'm going to start by putting a 2 in front of iron 3 chloride. That's going to give us 2 iron and 6 chlorine. And so then we are going to need to put a 6 in front of ammonium chloride to get our 6 chlorine. And that's going to give us 6 ammonium. We're going to need to put a 3 in front of ammonium sulfide. That's going to give us 6 ammonium and 3 sulfur. And now everything should be equal, so we're going to put a 1 in front of iron 3 sulfide. And our last example here, we have solutions of magnesium nitrate and sodium hydroxide being combined. So we have magnesium nitrate. Magnesium is a 2 plus, nitrate is a 1 minus. So the formula there is going to be MgNO3 in parentheses, put the 2 on the outside. We're told that it is a solution, so that is going to be marked as AQ. Sorry. And then we have sodium hydroxide. Sodium is a 1 plus. Hydroxide is a 1 minus. So we're going to have NaOH. Mark this as aqueous. So we want magnesium and sodium to switch places, switch partners. So we're going to have magnesium and hydroxide paired together now. So this is going to be MgOH2. And if you look at your solubility rules, that will be a solid. And then we're going to have sodium and nitrate going together. So that's going to be NaNO3. And that is going to be aqueous. So now we need to balance this out. In the reactants, we have 1 magnesium, 2 nitrate, 1 sodium, and 1 hydroxide. In the products, we have 1 magnesium, 1 nitrate, 1 sodium, and 2 hydroxide. So we're going to need to put a 2 in front of sodium hydroxide. That's going to give us 2 sodium, 2 hydroxide. 2 in front of sodium nitrate. That's going to give us 2 sodium and 2 nitrate. Now everything is equal, so we're going to go back and fill in with ones. So that is all with predicting products. You need to take a look at your predicting products practice in your packet. And you will have a quiz over predicting products in class next class. And also, you need to start preparing for the test. It's going to be at the end of this next week. So if you have any questions, make sure you come in and see me and get help. Thanks, and have a great day.